This is AP Chem, Chapter 4, Chemical Reactions, and this is stoichiometry. So stoichiometry is really one of the key parts of chemistry, where we're going to study the amount of substances that are consumed and produced in chemical reactions. And the first step is always to have a balanced equation, and then we can figure out how much products we're going to make. Or let's say we wanted to have a certain amount of products produced. Well, then how much reactants do we need? And we can figure that out. And we're also going to move up to eventually, why do chemical reactions stop? Which one of those reactants is used up? That's called the limiting factor, the one that stops it. So we're going to spend quite a bit of time on stoichiometry. But the steps are always the same. Write a balanced equation, state what we know and what we're looking for, and we're going to have something new, but it's not really new. We're just going to state it a little bit different, is the molar ratio, how we get from what we know to what we're looking for. So let's go back to that example I did in class, where I poured those two clear liquids together and we made that precipitate, and we produced this precipitate here, this yellow precipitate. We can talk about what we did. And we could say, hey, we took 4 grams of potassium iodine, combined it with an excess amount. That means when I say excess of lead 2 nitrate, that means I have more than enough. Just like we have an excess amount of oxygen in the room, at no point are you running out of oxygen to breathe. There's always an excess amount in the room. There's an excess amount. What's going to stop the chemical reaction is the potassium iodine will run out. And we want to know how many grams of precipitate will we form. Well, first we write down our balanced equation. We had the 2 clear liquids. We saw that they were aqueous. We made potassium nitrate was aqueous. And our solid, the yellow stuff that fell to the bottom, was the lead iodine. And I'm going to state right away what I have. I have 4 grams of this. I have a excess amount of this. And I want to know how many grams of the lead iodine I can make. So I just have this equation back at the top here in the notes. And notice these coefficients in front, again, those are our ratios that we use to figure out. We're saying it takes 2 of these, 1 of these, 2 moles of potassium iodine, 1 mole of lead nitrate, and we'll make 2 moles of potassium nitrate and 1 mole of lead iodine. So to start the problem, well, the molar ratio is what we have from here. Here, we have 2 moles of potassium iodine, and we're going to make 1 mole of lead iodine. That is the molar ratio we're going to use in our problem. So let's just get to it. And we always must go through moles. Everything goes through moles. So anytime you have a value that is not in moles, get it to moles. I have 4 grams of potassium iodine. I'm going to need to change that to moles first, and then get over to what I'm looking for. So let's look at it. Start with what I know. I have 4 grams of potassium iodine. From the periodic table, I can figure out the molar mass. So this is from the periodic table. The molar mass of potassium iodine from the periodic table was 166.01. And notice I have grams cancel out with grams, and potassium cancel out with potassium iodine. Everything is canceling out. Here's my new thing. This is my molar ratio, and those are the coefficients that I got from up above. 2 moles of potassium iodine makes 1 mole of lead nitrate. And notice moles cancel out with moles, potassium iodine with potassium iodines. If I stop the problem right here, I would know how many moles of potassium iodine I produced. But they asked for grams. So how do I get from grams to moles? Well, back to the periodic table. From the periodic table, I know 1 mole is equal to 461.0. I take everything on top, divide by everything in the bottom. I had 2 sig figs here, 4 here. This is an exact number, doesn't affect. 4 sig figs, so my answer is allowed 2 sig figs.